Good afternoon, everyone. I'm Jingchan. Firstly, I'll introduce important information about the Galiwenku community. The majority of the population of Galiwenku is Aboriginal. The main touring is place and the sandy beaches. Temperatures in Galiwenku range from a high of 35 degrees to a low of 17 degrees annually. Cooler facilities may be needed in the summer when temperatures are highest. After Cyclone, most residents' homes were destroyed and made uninhabitable. Local residents took refuge in a school and set up temporary tents. These tents were very small and sanitary conditions couldn't be guaranteed. The reconstruction of the houses faced great difficulties. On the one hand, the local facilities were underdeveloped, and the disaster was severe. On the other hand, the Aboriginal people were reluctant to leave their homes. Therefore, I chose to address the issue of post-cyclone housing for the residents. If shelters are not adequately ventilated, they become hot and humid inside. This has a negative impact on the health of the residents. Adequate ventilation is crucial for the Galiwenku community's shelters. Therefore, I believe that a shelter that can sustain their daily lives for a long period of time is better for the residents of Galiwenku. Let's move on to the next part. In the final design, on the outside of the shelter, I set up the entrance to the shelter as a cool resting area. First of all, the roof of the shelter was extended and supported by metal pipes, which turned into a gazebo. The shelter has one door and three windows at the different points in the shelter. This is for ventilation openings for air convection. When the door and windows are opened, the air is convected through the windows for rapid ventilation. This ensures that the indoor temperature drops and that ventilation is necessary for human health. 4 small solar panels on the roof can provide power for mobile phones, important communication sources, and interior lighting equipment. The house number located next to the shelter is used by locators to identify their shelter and to register the exact location of their residents. Residents can be assigned a location based on their original neighborhood. A clothesline is attached between each shelter and the house number. This solves the problem of residents hanging out their clothes and reduce indoor moisture. I designed two interior configurations of the shelter to be used by residents with different needs. Firstly, the single occupancy shelter is divided into a cool resting area at the entrance, a dining area, a bedroom area, and a toilet. These areas are designed to accommodate the residents' daily lives. The total length of the single shelter is 5 meters, with 1 meter for the cooler area and 4 meters for the living space. The total width is 3 meters and the height is 2.5 meters. This is a model of the internal structure. Additionally, the family shelter and the single shelter have essentially the same areas. It's very convenient for families with parents living with their children and families with elderly caregivers. Family shelters have a study area in each of 2 rooms. allowing each to study or work separately. The total length of the family shelter is 5 meters, with a meter for the cooler area and 5 meters of living space. The total width is 4 meters and the height is 2.5 meters. This is a model of the internal structure. These are photos of an isometric model. This on the reference list. Thanks for your listening.